now that we are heading close to the end of the section that was modeling the application layer, it is appropriate to look at some problems and seek their solutions. We shall solve the problems in this module which relate with the effects of individual latencies in the overall network latency, and we'd look at the performance of HTTP protocol in the context of persistence. Let's look at the statement carefully. Consider an institutional network which has connectivity to the internet. The users are accessing internet to download objects. If we assume that the average object size is 850 kilobits, which is typical size of a web page with embedded images, and the average request rate from the institution's browser to the original server is 16 requests per second, because at one instance of time there may be one user active with not very frequent requests making from his browser, but from the institution's point of view, 16 requests per second is a fairly practical assumption to make. Let's further assume that the amount of time it takes from the stub router on the internet side to access the link that forwards the HTTP request until it gets the response is 3 seconds on average. This is the overall internet delay. With this as the underlying network, you are expected to model the total average response time. It means you actually have to sum up the averaged values, which comprises the average access delay and the average internet delay. For the average access delay, there is an expression delta divided by 1 minus beta. Delta refers to the average time required to send an object over the access link. This is the transmission delay, and beta is the arrival rate of the objects to the access link. So beta is going to be greatly affected with the requests per second that the institutional browsers are making. Once you've modeled the total average delay, the next requirement from the same scenario is, now if you suppose that there's a cache which is installed in the institutional LAN, so it is now going to help the queries get resolved locally. Now if the miss rate is 40%, it means 60% of the requests are entertained locally by the caching server. Find the total response time. So it means we are expecting that with the installation of a caching server on the local premises of the institution, a reduction is expected to be observed in the overall response time. Now, if we want to look at the performance of HTTP, let's look at the problem. Suppose that there is HTML file on a web server which embeds or references 8 very small objects. If, for the sake of brevity and ease, the transmission times are ignored because the transmission times are dependent upon the overall throughput and the object sizes, we are not interested in that at the moment. What we are interested in is how much time does it take when non-persistent HTTP connection is used and the browser is configured for 5 parallel connections. Now here is the catch. The catch is, when we talk about 5 parallel connections, each connection can get an object. But this is all happening non-persistently. So you have to mix up the two and find the answer. If it is going to be 18 round trip times, 6 round trip times, 3 round trip times, or you do not agree with any of these.